let me work out an example of an integration by parts problem. Sometimes these problems don't look to be integration by part problems and may arise from other problems or other substitutions. So for example, suppose that we want to find the following integral: 0 to 4 e to the square root of t dt. In this case, it seems that integration by parts is not the best way to go with this. But we actually find out that after doing a substitution, integration by parts will appear. So in here, let me start first by doing a substitution. So I'm going to make the substitution u equals square root of t, which will give me du equals 1 over 2 times the square root of t dt. So again, I'm starting just by using a normal u substitution. If I do this, we have that the integral becomes the integral of e to the u, and instead of dt, I'll get 2 times the square root of t dt. So notice that I can rewrite this part in terms of u again. So this will become actually the integral of e to the u 2u du. Finally, I can rewrite the limits of integration just by plugging into my original substitution. So this will be the integral between 0 and 2. Now we can see that the integral that I arrived to is actually an integration by parts, because I have that this is 2 times the integral of u e to the u du. Now I can assume my integration by parts formula. So I have that my u in this case is going to be the first term and my v is going to be my second term. Notice that I already use the letter u, so I'm just going to use v and dw. Okay, so I'm not doing anything strange. I'm using just, instead of u and dv, I'm just labeling as v and dw. It's just a different letter. So I have that my first part of the integration by parts is going to be u, and the second part is going to be the exponential. This means that I have du equal dv, and then w is going to be just e to the u. Now I can rewrite this using my integration by parts formula as the integral of w times v minus the integral of w times dv. So this becomes v times w, which is u e to the u, minus the integral of w times dv. So it's just e to the u du. And notice that I have this evaluated between 0 and 2 and 0 and 2. And that we have an overall factor of 2 in front of everything. So I'll just copy that factor in front of everybody. And this is actually something that I can compute, because this becomes 2 times u e to the u between 0 and 2 minus 2 e to the u between 0 and 2. So then I have these to be 2 times 2 e to the u minus 2 times 0 times e to the 0, that's the first part, minus 2 e to the 2 minus 2 e to the 0. So I'm just evaluating these numbers. Then this will give me 4e squared minus 0 minus 2e squared plus 2. And in the end, this gives me 2e to the 2 plus 2. Notice that my result is a number, so I don't have to go back into the original expression that I had. In other words, for certain integrals, we can combine different methods. And even if we don't start with an integration by parts, in the middle, we actually end up with something like that.